Okay, so we're gonna use them for the warm-ups and the lesson today. We're actually gonna finish them. Um, this is the one thing that I would keep in my folder at all times. Even into second semester, I would like this would be the one thing, even when we finish a new packet, carry this with you the whole time. Um, and if you lose it, that'd be sad. Just saying. Okay, but let's go here. So number 15 says a cubic. And so I look at the general equation of a cubic, y equals a x minus h cubed plus k. And um, instead of memorizing all of these, you're supposed to notice the pattern. So most of the time, A is in the front of whatever the grouping symbols are. X minus H is usually inside, and then K is on the outside. It helps you not have to remember. Cubic just means cubed. There's nothing fancy here. But also our blue sheets tell us the inflection point is HK. So I'm going to put HK up here on inflection point, and then passes through is going to be my X. Okay. 17 equals A, -4. Okay. Now pause here. We should all know this is minus a negative, so I'm going to make it plus. Any questions about my plugging in? Are you sure? Okay, now rescue the 1 out of there. Okay, now let's review how to reduce a fraction on the calculator real quick. Because well, first of all, you should know 9 goes into both of these. This is not really one that's necessary, but let's just go over it again. So 18 divided by -27. So I'm doing 18 divided by -27 right here. Horrible, disgusting, repeating decimal that I hate. What do I push? Anybody remember? Math, enter, enter. Ah, beautiful reduced fraction. Okay, final answer, y equals -2/3 x plus 1 cubed minus 1. So what's your confidence level with something like that? You finished? Okay, as long as you figure out what the pieces parts are and where to put them. Okay, what type of graph do I have on the next one? What is this thing? Cube root. Okay, so hopefully we're starting to kind of memorize a little bit just for our convenience, the different shapes. Here's the shape of the cube roots here, which is sideways cubic, sleeping cubic. Ah, I'm funny. Okay, so cube root equation is y equals a cube root x minus h plus k. Okay, and my inflection point is HK, and that's this one here in the middle of the squiggle. So that is -1, -2 is HK. And then this other point that they gave me down here is my XY. So that's 7, -3 -3 equals a cube root 7 plus 1 minus 2. Plus 2, get the 2 out of there. Cube root of 8, I wonder what that is. Huh. Dump. Real quick, when we did this problem before, this was one test and a quiz ago. It was a bit ago. It was a while ago. There were a bunch of sweet children who, instead of just finding this value, tried to like cube both sides for some reason. They solved for A, forgetting that if you cube everything, you also need to cube the A. So that was kind of a, I don't know what happened there, but you don't need to, you just, those things come out to numbers, so you don't have to making it fancy, too fancy. Okay, anyway, final answer, y equals -1/2 cube root x plus 1 minus 2. Thing about warm-up, we're all about Bruce's today. So you actually don't need your notebook at all. Your notebook can just wait for you to work on homework. Just kind of exciting. So we're gonna do two problems. The first problem is really just you guys watching me mess around on Desmo to figure out like different things about log graphs. I have to be honest and tell you that we're only scratching the surface of log graphs in Math 3. There's a lot more that can happen that, and some of it I don't actually understand. I've been bugging Coach G and Mr. Knight to explain some stuff to me. And they keep explaining it to me and I keep like rejecting their explanations. So even this morning, I asked Mr. Knight a question about log graphs and he was like, because it is, and I was like, And I realized that my conversation with him is far past whatever you'll need in this class, but it bugs me and I don't get it. So anyway, we're just wading into the baby pool of log graphs. There's a lot more, but we're gonna treat it kind of like a hyperbola where you just sort of wing the graph, which is fine. It's good enough for us. To be honest with you, I don't really know how in depth it gets in like pre-calc and calculus. I feel like this is mostly good enough unless you're like studying math for a living. So anyway, here's the homework: 78, 81, 83, 84. Why do lumberjacks make good musicians? Because of their natural logarithm. Oh,
That's pretty good.
yeah. Lumberjacks. Anyway, log jokes are sparse, people. Sparse. I took what I could find. Thank you for humoring me. Okay, actually, I didn't want to do that. I wanted to do this, that. Okay, so Desmos, here it is. You guys know about this thing down here that gives you a menu. And if you hit the functions button, There's a lot of different stuff in here that you can use. But what I want you to notice is that, hold on, let me zoom in. There's a log. This is natural log here, this ln, and then the one that I'm going to click here is log base a, because we're going to use that. So if you are messing with this on Desmos, just so you know, it's located in the functions button, and the functions button is located in the little keyboard thing. Okay, here's the one. I think we graphed this one yesterday on the graphing calculator, log base 7 of x. And I told you that Desmos was going to be cool about this, that your graphing calculator was not going to be cool about this. Desmos shows the asymptote and then how it goes all the way down. The graphing calculator is just like, nope, I'm out. So just remember that line goes all the way down. Okay, so what we're doing for number 75 is we're just going to mess around with this so you can see what's allowed and what's not. What would you expect if I put a +2 on the end of this? What would happen? Two up, that's K. Okay, now what would happen if I put the +2 inside? Yeah, okay. So there's your vertical shift you expect, your horizontal shift you expect. That's not really a big deal. What about this? Reflect over the x-axis, what you expect. Okay, now I'm gonna put a 2 here, and I want you to see it doesn't really change the sketch very much. Kind of like a hyperbola. I told you guys not to worry about the A value because it's coming along the asymptote anyway. Same thing here. You're just going to come along the asymptote anyway. So when you have an A value in your sketch, you don't really care because it's getting closer and closer to the asymptote. This is the stuff I want to talk about though here. What kind of stuff can the base be? The base is 7. Let's look at a base of, well, let me do it. Wait, where'd my base go? Do I have to do it over? Stripes. I'm afraid to screw this up. Okay. Where is it? Disappeared. Okay, what is this telling us? Yeah, you can't have a negative base. Okay, so negative base log graphs don't happen. What other kind of weird possible numbers can we try? 1. I heard you say 1. That's so, how do I fix that without it? How? No, I don't. Okay. I'm so irritated. I love you, Desmos, most of the time, but right now, killing me. Oh no. Oh geez. Hmm. Where'd it go? Okay, now think about this one. This one you can actually think about being kind of dumb. Like if you do, let's pretend that equals y is on this side, and you do the guy in a circle, like 1 to the y equals x. It's not very exciting. Like because 1 to the everything is 1. It's not gonna make a curve and stuff. Okay, what's your other weird option? Now you have to watch me type it all in again. Maybe not. Okay, so is the trick to type
Hey,
0? Nope. Okay, what about decimal? What do you think about decimals? Do you think decimals are okay? Huh, decimals are okay. Okay, for my mathy people, the base of the log is actually the horizontal stretch factor. And we're not going to play with that too much. The other thing we're not going to play with in this class, and this is the thing I was talking to Mr. Knight about this morning, is this. We're not going to play with a reflection over the y-axis by putting a negative x inside. Okay. And unfortunately, this may have unleashed the beast in your mind to think about, oh crap, do we have a negative inside all of the parent graphs that we did in the blue sheets? Yeah. We don't care about that except for two of them. Do you know which two those are? Which ones do we care about a reflection over the y-axis? What?
Okay.
Which kind, special kind? Sleeping parabola. That one has a reflection because it's sideways over the y-axis. The other one is the square root that we did the first week of school, where it comes down like this or it swings this way. Those are the only two where we had any kind of negative x situation. I don't want you to worry about it. What I want you to actually consider is the fact that we didn't do everything. There's still so much. We're scratching the surface in here, and that's fine. It's good enough. Okay. So we're gonna abandon ship on this. We're gonna find our blue sheets. Find the last page. And we're gonna start filling this out. Okay, now over here in this blank space, we're gonna write some notes to ourselves. We're gonna write B cannot be 0. Because remember, no graph showed up. B cannot be 1. And B is positive. Okay, general equation. Y equals A in the front, just like you expect. Log base B x minus h plus k. If you had to guess, would you have guessed that that was the general equation? Feel like that's what we would expect. A in the front, h in the parentheses, k outside. The log base B, you haven't really played with that too much yet. Do you guys remember in the exponentials, I actually had to pick a base? I don't know if you remember. It's been, how long ago did we do this? 2 months? If you look back here, here's the general equation for exponentials. And then down here, when I did an example, I had to pick B equals 2. I'm going to use the same B equals 2 for logs so they match up. Okay. You guys good so far? Okay, we're going to skip the locator point for a second and go straight to the asymptote. We know that these have a vertical asymptote. So vertical at x equals h. And now we're going to come up to the locator point because we know our locator point cannot be HK because HK will be on the asymptote. That's not where the curve is. So we're going to make ourselves a note. HK is on the asymptote. So dot, dot, dot. locator point is h plus 1 comma k. We're just going to move it one over. This is one of the things I don't understand. That I've been asking Coach T and Mr. Knight to explain to me, and I've been unsatisfied with their responses. Should I not be able to take the locator point of an exponential and just flip it because this is its inverse? But I can't. Okay, but I can. Okay, this is their explanation. That point exists, but it's not the point we choose to use as our locator point for logs. They say that you should just, for the easiest, you should just come one off of the asymptote. Because it's easier to just come one off the asymptote. Anyway, so apparently in Mr. Knight's mastery class, he's teaching the locator point and then a bonus point, which he has a completely other formula for, and then he's like got the y-intercept and they're gonna drop all of those. But in our class, we're gonna do the locator point and then we're gonna wing the curve like we did with the hyperbola because that's plenty. Our graphs are gonna look very similar to theirs. We're just gonna do slightly less work. But I don't know. I have to stop caring about it. I gotta let it go. I just have to. Like I have to put my brain at other things. Okay, anyway. As usual, we're gonna save the end behavior and domain and range until after we graph the parent graph. So we're gonna come down here and I'm going to declare that for this B is 2. Okay, and so what we're gonna end up graphing in whatever original color, if you guys are doing different colors, we're gonna end up graphing y equals log base 2 of x. And we're gonna actually put stuff over here because it's gonna be really helpful. So in this particular, this is a parent graph that I've chosen. I chose log base 2. The h is 0. So the asymptote is going to be on the y-axis, which is really hard to draw. So take a minute. Put the equation of the asymptote down here, x equals 0. Our locator point is going to be h plus 1 comma k. What is h and k in a parent graph? What's h if there's nothing in the parentheses? 0. What's k if there's nothing outside? 0.
What is the change?
Oh, that should be v, huh? You're my favorite right now. You just fixed the whole thing. You're amazing. Okay. 1 comma 0. Okay, and then what you're going to do is you're going to come along the asymptote through that and then wing the curve. What I mean by wing the curve is just sketch it. Okay, now you're not going to like this part, but that's okay. Maybe you will. I don't know. Log graphs don't have any left end behavior. And I always tell you, like, left arrow, right? And you guys are like, but there is a left arrow, it's right here. Except for the end behavior is supposed to be going toward infinity. And so there, it's not going toward infinity. I'm going more to the negative infinity over here. But you see the arrow stopped. So there's no left end behavior for these. Because they're not going to negative infinity. It doesn't happen. So none. Okay, but there is right end behavior, and that is going to infinity. But remember, we are going to probably have a negative a situation that's different. Okay, and then the domain is x is greater than h. And just plain greater because it's not going to touch the asymptote. And the range, that's the wrong R. The range is all reals because it goes forever up and down. Okay, Mrs. Talbot, you just said it's always greater than h is kind of a lie. If you have a negative in front of the little x in the parentheses, it would flip the other way. But remember, I said we're not going to do reflection on the y-axis in this class. That's too much. So for us, it's going to be x is greater than h. I just want you to know there's more out there. You don't know everything. Neither do I, apparently. Okay, last bit, we need to graph the transformed one. So get out your other color, whatever that was. And this is the last time I'm going to ask you to locate the point 3, 4. Okay, I'm gonna go a little slow here. First, what is the asymptote? Okay, so scroll back up. Vertical asymptote at x equals h. 3. Okay, so vertical asymptote x equals 3. And your point that you made for 3, 4 should be on that. Which I'm hoping that that illustrates why you can't use that as a locator point, because it's not on the curve itself, it's on the asymptote. Do you guys have any questions about that? Okay, now we're going to do the locator, which is h plus 1, comma k. H is 3. So you just jump one spot over. Does that work every time? Yeah, trust me, I did like 10 of them because it was really bugging me why I couldn't do it anyway. Okay, last thing you need to know. A is negative. I told you not to worry about the 2. A is negative, so it's going to come down the asymptote from the top. And go that way. Maybe I shouldn't have it go right to the Luckily, I taught you how to use the graphing calculator to check these if you need to. But, that's all the stuff I would care about. If you're taking a quiz, you could just put the vertical asymptote in, go to HK, then jump one spot over for a dot and then wing the curve either from the bottom or from the top, depending if it's positive or negative. That's really the extent of where I need this to be. Do you have anything you want to ask me that I might not actually know the answer to, but I'll try really hard? Nope, that's it. You're sure? Yes, honey. It's going through 4, 4. It's going through this point that's one dot away. So I came along the asymptote and then I went through 4, 4 and then curved off. I don't know, and I don't really care. I just know that it hits that and then curves off somewhere.